Okay, so I'm going to start on, I think it's the third page, problem number 6. And again, if you have a specific question on a different question, I can do that. But I'm going to start here at 6 for now. All right, so number 6, a fair 6-sided die is rolled. Fair just means it's not a trick one or anything like that. What is the probability that it is not a 1 or a 6? Not a 1 or a 6. Okay? Well, how many sides do we have total? We still have 6 total. It's not a 1. It is not a 6. So of those 6 choices, if you take away those 2, that is 4 out of 6. Where it's not a 1 and it's not a 6. So it could be a 2, a 3, a 4, or a 5, which leaves you with 4 out of 6. Write your answer as a fraction. Kind of tricky here. It is a fraction. Technically, you should try to reduce it. It doesn't say not to, so you could write 2 out of 3. I will make sure they're specified on the test for sure. Okay? Letter B, what's the probability that an even number is rolled? Well, if you have the die, you still have 6 sides. That's your denominator. And an even number, my even numbers would be 2, 4, and 6. Any of those 3 could be chosen. So that is 3 out of the 6, which simplifies, if I divide by 3 over 3, to 1/2. As a decimal, how would I find that as a decimal? You take 1 divided by 2. Start with the top number and go down. 1 divided by 2, so that is 0.5. And the last one, what's the probability that a 7 is rolled? Well, that would be out of 6. There is no 7 on a regular fair-sided die, so that is 0 out of 6, which is 0. Okay? All right. So, those just joining us, we are working on review problems. I started here in the middle, and those are the answers that I got. Next, I'm going on to number 7. Fred, Chris, Emily, Alec, Jenny, and Izzy. Please be very careful when you are counting them. I can't tell you how many people are making silly mistakes because they cannot count the names correctly. So maybe number them, all right? They are entering a talent competition. Assume all people have the same chance of winning. What's the probability that Alec wins? Okay, well, we're talking about who wins. All right, who wins?
And then,
Okay,
if I don't like that,
if you don't like that, hey, I can hear you.
sorry.
That's okay. So there are 6 people. Any of those 6 people could win, okay? The probability that Alec wins, he's one person out of the 6. Everybody has an equal chance, so that is 1/6. Okay? 1/6. Now, how many possible outcomes are there? We are not just talking about first place, okay? Not just first place. We are talking about all outcomes for the entire talent competition. In other words, who comes in first, who comes in second, who comes in third, fourth, fifth, and sixth. So I like to do these little things, which I guess I can't do them very straight. How many people could come in first place? If they all have the same chance, that means 6 people could. Once somebody comes in first place, then only 5 could come in second place, and then 4, and 3, and 2, and 1. You multiply these all together. 30 times 4, I don't know. Oh, geez. 6 times 4, 24 times 30. I probably should know this. Probably 720 if I had to guess. 30 times 24, 720. So another thing that I will tell you, when you say 6 times 5 times 4 times 3 times 2 times 1, all the way down to 1, that is also, remember, 6 factorial. Okay? And finally, since order is important here, because whoever comes in first, that is important, would be anybody. Whoever comes in second is less. That is also the same as a permutation of a total of 6 items, looking at all 6 at the same time. So all of these things are all the same. Okay? All the same. So remember, when we're talking about outcomes, we're not just talking about first place. We're talking about all 6 for those 6 students that are participating. Okay? All right, let's go down to number 8. There are 19 students in a class. 5 are selected to be eligible for a coupon to use for a free homework coupon, like no homework. Would you use a permutation or a combination to calculate the number of possible ways the students can be selected? Is order important? Remember, pom-poms, permutation, order matters. So is order important here? What say you? You can put it in the chat. Do you think this is a permutation? Do you think this is a combination? Well, this would be a combination. Order is not important here. Okay? It doesn't mean, oh, you get the first free coupon for no homework. You get the second one. That doesn't matter. Okay? How do we know? Well, that's what you would put here. Order is not important. So it either is important or it's not important. For a combination, not important. So calculate the number of possible ways the students can be selected. You must show your calculations. I did not show you how to do those calculations. You will have, hopefully, those yellow calculators. So you always start with the total, 19, and maybe I will show you how to do it now. It is a combination, and we want 5 taken at a time. Okay? Let me show you the calculation. So you start with 19 and you have 5 taken at a time. Basically, you are doing 19 going down by 1 each time. So that's 19 times 18 times 17 times 16 times 15. And you are doing this for 5 different numbers. Okay? So whatever number that is, you start with this number and you multiply by going down 1 for that many numbers. So 1, 2, 3, 4, 5. Divided by whatever this number is, and you could say factorial. So starting with that number, you go down and multiply by all the numbers smaller than that, down to 1. So that's times 4, times 3, times 2, times 1. Okay, so I could multiply that out, but I'm going to use my handy dandy calculator and see what the combination is here, and then we'll see if it happens to match. So you put 19 in first. You would hit the probability button, as you recall. Make sure you go down to combinations. Put the 5 in. Okay, and this gives me 11,628. So this is the correct answer. And I definitely will go over a problem like this tomorrow to show the calculations. Not even sure I will expect that though. So here I notice I have a 15. I also know that 5 times 3 is 15. So I'm going to cancel those out. And this is just simplifying before I actually multiply. I see I have a 4 times 2, which is 8. And I have a 16 here. So 16 divided by 8 leaves me with 2. So if I take 19 times 18 times 17 times 2, I'm hoping that gives me 11,628. 19 times 18 times 17 times 2, and it is 11,628. Questions on that? I will definitely do one of those tomorrow. If it were a permutation, like above, if it's 19 permutation of 5, then it's just the numerator, which is 19 times 18 times 17 times 16 times 15, where order is important. Okay? With a combination, you divide by whatever that number is that comes second by its factorial. All right. You guys with me at all still? Let's look at problem number 9. 11:06. Okay, we got about 10 minutes. So Juan is choosing an outfit for school. He has 14 shirts, 15 pairs of pants, and 12 belts. How many different outfits? This is not probability. Okay, I don't need a numerator over a denominator. It just says how many different outfits. So I'm looking for a whole number answer. And to find that, fundamental counting principle says whatever your choices are, you just multiply all of those choices together. So 14 times 15 times 12 gives me 2,520 different outfits. And when you are doing these kinds of problems, yes, you do need to show the work, show me what you're multiplying, and you have to show me the answer. The only thing that we're doing is just reviewing the whole. That's what we're doing right now, Cristobal, but there is a separate Canvas homework assignment that you do need to do that is worth 10 points, and that is due by tomorrow midnight. But yes, right now we're just going over the review. I hope that answers your question. All right, so number 10, your phone has a 6-digit code that can be used to unlock the home screen. The numbers 0 through 9 can be used. Question: how many numbers are we dealing with if we have the numbers 0 through 9? How many numbers? Anybody? Come on. Put it in the chat or just unmute yourself.
9.
It is not 9. You can say 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9 numbers. Then 0, which you didn't
6.
count, is 10. Right? It's always one more than what it looks like. So with 0, it's 10. So if I had 0 to 6, that would be 7 numbers. All right? So to do this code, would you use permutation or combination to calculate the number of possible unique codes that can be created? Would that be a permutation or combination? Survey says should be a permutation because order matters. So permutation, justify your answer. Order matters. Okay? If your code on your phone happens to be 231, whoops, you guys can't see that very well. Okay? 231 in a permutation, 231 is different than 123, which is different from 321. Okay? But in a combination, order is not important. So all of these would kind of be similar because order is not important. But if you're talking about putting in a code, yes, order is important. Okay? So order matters. All right, how many possible combinations are there? Now this, I don't like that we use that word combinations because it's how many possible choices are there if the digits are allowed to repeat. So we have a 6-digit code and they are allowed to repeat. 1, 2, 3, 4, 5, 6. So how many choices do I have for that first spot? If I'm using the numbers 0 through 9, you would have 10. Okay? The digits are allowed to repeat. So whatever I got in the first one, I can use it again. That means for the second one, I would also have 10. And for the third one, etc., etc. When you multiply these all together, you get 10 times 1, 2, 3, 4, 5, 6. 10 to the 6th power. You can do that on your calculator. And that is a 1 with 6 zeros. Anytime you have 10 to a certain power, the power that it's raised to tells you how many zeros you have. So that is 1 million. Okay? How many possible combinations are there if the digits cannot repeat? Well, it is still a 6-digit code. Okay. How many possible combinations? Well, in the first spot, you could have 10. But they cannot repeat. So once you've used one of your numbers there, you can't use it again. That means you would only have 9 to choose from for the second. Then you can't use the first 2, which means you would only have 8 left. And then 7, 6, and 5. So if you multiply these together, this would be 90. This would be 56. This would be 30. This is one way to do it. 90 times 56 times 30. 90 times 56 times 30 is 151,200. Now, this also is a permutation. This is a permutation of 10 different digits taken 6 at a time. Okay, starting with 10. So if I do that, I'm pretty sure it is, permutation 6 at a time, I should get the same thing. And I do. So 151,200. Okay. So you can multiply it out and get the answer, or this would be a permutation. It is not a factorial. A factorial means I would go from 10 all the way down to 1. It would look like this, but it is not a factorial. Okay? Ooh, watching our time. 06, 03. We got 3 minutes. Okay? I probably can do this one really quickly. Number 11. A random sample is conducted. Based on the sample, it's estimated the proportion of the population that has a certain characteristic is 0.37. Let's say it's maybe the probability that people have a pet fish. Okay, maybe a third of people do. And that is 0.37. But we have only talked with the sample. We are going to put it out for the whole population, but we have a margin of error of 0.09. And yes, I just made this up. Okay, I just made it up. So we need to add and subtract, okay, 0.09 from that amount to get an appropriate range, okay? Because we can't say for the whole population that 3,700ths of the whole world has pet fish, okay? But if I add 0.37 and add 0.09, again, make sure you are lining up your decimals when you add. You are going to get 0.46. That's on the high side, okay? And then if you subtract 0.37 and subtract 0.09, you're going to get 0.28. That is on the low side. Okay, so that means my range goes from 0.28 to 0.46. Now that's an appropriate amount. Okay, and the word plausible here just means possible. Is it possible the proportion is less than 0.28? Not really, not within that margin of error. So it's not less than. Is it plausible that the proportion is exactly 0.37? It could be, but it says most appropriate. So let's keep going. Is it possible it's greater than 0.46? No, 0.46 is the largest. Is it plausible or possible the proportion is between 0.28 and 0.46? Yes. So this is the best option. It could be exactly, but we don't know that for sure. So this is the best one. Okay? So, finish any and all homework. You also need to finish the review. Okay? Weekly Canvas activity. There is a new one for 126. Also, there is a new Canvas homework assignment, and that is due tomorrow. It is over review stuff for today. Okay? All right. Thanks for being here. You guys have been great. Hopefully you got some information, and I will hopefully see you in person tomorrow. Bye-bye.